Welcome, ladies and gentlemen. This is 8-3 solving two-step equations. We're going to be solving them this time instead of just writing. You will still need to write them, but we're going to walk through how do we solve for them. So I still haven't solved my audio problem, so I'm going to be doing the talking. The shaky bagel baker decides to just divide by 13 to decide how much charge for each bagel. Does his method represent the price per bagel his crosstown rival charges for the bagels from 1 to 13? Explain your reasoning. So he's saying, oh, I'll just take that and divide it by 13 to get the price per bagel. And crosstown says if you buy 1 dozen, you'll get the 13th donut for 13 cents. So that way you're paying $5.53 for 13. So you're going to need to pull up your companion page or pull it out at this point and go ahead and work on it. As this is loading, go ahead and pause to get yours. If you're using it from this page, that is fine as well. You'll want to just pause so that you can get them as you need to. Okay, so feel free to pause if you haven't already done so. And ladies and gentlemen, as you're returning, I'm pulling up the solution so that you can see. I'm kind of hoping that this kind of is ringing a bell since we just talked about how to write this equation in the last one. And as we're going through, no, just dividing that by 13 is not how the bagel across town is doing it. Bagel store, I guess. So the situation that we need to represent is if you're buying 12 bagels at a certain price, and then you buy one more bagel that's just at 13 cents, and your total is $5.53. We'll find out what the cost of 12 bagels plus that 13 cents for the 13th bagel should equal $5.53. This hopefully is looking a little familiar to you. And let's see, we have 12 bagels times the price of 1 plus 13 cents for that 13th bagel should equal $5.53. I want you to think about something before I go on. When you're putting things together in math, we use order of operations, often called PEMDAS, parentheses, exponents, multiplication, division, and then adding and subtracting. Think of that as how you get ready in the morning. You're putting yourself together to come to school or go to the mall, and you put your slacks on or your pants on, and then you put your shoes on. And that's very true if you're wearing skinny pants. Then when you come home, you need to undo and get comfortable. Well, that's how we're solving for an unknown. We need to undo our math equation, and so we need to take our shoes off first and then take off our skinny jeans or our pants and get comfortable clothes on and such. So we need to undo. Well, order of operations says we start with parentheses and we end with adding and subtracting. Well, when we want to undo it, we need to go backwards. So we're going to do any adding or subtraction first. We need to be writing that down. My little pen didn't quite work there. Add or subtract first. That is what we have to do when we're trying to solve an equation. We add or we subtract first. It's just like when you get home, you take your shoes off and then you get changed out of your school clothes or your mall clothes into your PJs or whatever it is that you like to lounge around the house in. So you add or subtract first. Make sure you have that written down. Then you can start to do things like multiply or divide. So if this is first, then, and I'm just going to use symbols, the asterisk for multiply, and then the division sign because I'm a little quicker at that, then you're allowed to do those operations. So let's see. They have 12 times B plus 13 cents equals $5.53. We want to get everything away from this B so that we have B all by itself and we can find out what it equals. So we need to do add or subtract first. We're going to take 13 cents away. We're doing the opposite of what we see, and I think I have no, I don't have a highlighter. I just have this little pen. So we have plus 13. What's the opposite? Negative 13. And whatever I do to one side, I've got to do to the other because I have to be equal. right? And I'm trying to make this like a little sunshine because we want to be equal and we want to keep things happy. Okay, so I'm subtracting 13 cents from both sides. When I do that, I end up with 12 times B equals $5.40. But I have 12 being multiplied to B. The inverse option is dividing, so I can now do my division. I can undo my multiplication with my division. So divide both sides by 12. We get that number by what number is being multiplied to the B. So 12B, you divide by 12. And if you do one side, you do it to the other because we've got to be equal. So when you have 12 over 12, that's the same as 1. We now have just 1B or plain B equals $5.40 divided by 12. When we calculate that, we find that one bagel is going to be 45 cents. So we know if we go to town, he's going to match it if he charges 45 cents. So if I'm across town or I'm there, one bagel is 45 cents. Two bagels would be 90 cents. That's correct. Excellent. Okay, going to erase that. Let's scroll down. And it says the sample. You need to keep the expression on each side of the equation equal. So whatever you do to one side, you have to do the other because you have to be equal. So yours might say a little different wording, but that should be the basic concept. What you do to one side, you have to do to the other. You need to be equal. So let's move to our examples. This lesson will be put into two pieces because it's going to be a little on the lengthier side. If I need to, I'll cut it into 3 pieces. Okay, so the first part is going to be part 1, and we're going to walk a couple examples. Make sure you pause and you get down every step that you need to, that you're highlighting where you don't understand or something that you really need to know. You're making those comments and those marks as well as looking and going, what is it that I need to be able to do at the end of this? Not that I've asked you to master it, but you should be able to begin to solve 2-step equations. Also be a learning target. Okay, this is going to be a painful video. This is that monotone guy, so you're very lucky that the audio is not working for you. But I'm going to let him kind of roll through. I'm going to fast forward to a few things. So he's shaken these things and he's clicked them to where he wants. So he highlights something, he comes up and he clicks, and this is what he gets. When he wants it, and he comes over and clicks it. And then he has 2 and he has 2. He hits this because it's ready for him to work. So now we have the equal sign because that's the sign we're working with. Later when we do inequalities, you'll be learning to change this. If you wanted to watch this video tutorial, you can do that on your own. You would go under to practice examples part 1 for 8.3. So we're seeing he's dragging these down. He clicked them, he's dragging. So now we see that it changed to a greater than sign. So we need to handle that. We need to make it an equal. So he is going to place, what is he going to do? Let's watch for a second. Oh, so look, if he takes 2 away from this side, he's equal. What he's done to this side, he's done to this side. Other things. He knows he needs to subtract 3 from both of these sides. So he's going to grab these and it's going to be 0. And this is actually what we see he's doing right here. So these have time become 0. So 3x plus 0 equals -3. Now he's going to show you that you could break these apart if you made a mistake by picking up the hammer and coming and clicking them. So let me just go a little bit ahead because it is pretty important. So he says, you know what, I need to make this into 3 portions or partitions. So he's going to drag each piece into one of these rows. So 1x goes here, 1x is going to go here, and 1x goes here. Can you guess what he's going to do over here? That's right. He's going to separate the ones into each one of these. When he does that, we now can kind of see something. X equals, okay, he had to go show you. This is showing you all those steps. The work you guys always go, what am I supposed to show? I don't know. This is the work that I would, he can, well, I guess is when he had each one of these, the x and the -1.